When chronic fatigue, fractured sleep, and a heavy mood settle in, our first instinct is usually to look for a complicated solution. We test out expensive supplements, download sleep tracking apps, or ask our doctors for new pharmaceutical fixes to get our brains back on track. While we search for those complex answers, we often overlook a free, ubiquitous biological intervention. Natural daylight produces measurable shifts in human brain chemistry. To successfully harness it, we have to look at exactly how light alters our neurobiology, why timing that exposure to the morning hours acts as a specific weapon against stress, and how to build a precise, science-backed light protocol. This chart plots the data of over 13,000 adults. As outdoor daylight exposure increases along the bottom axis, reported symptoms of depression and insomnia follow a steep, distinct downward trend. We know this works on a massive demographic scale. But applying it as a clinical tool requires stepping away from broad population surveys and looking directly at the mechanical triggers firing inside the brain. The common assumption is that light exposure improves our sleep simply by suppressing melatonin, the hormone responsible for making us drowsy. Looking at this chart tracking melatonin levels over a 24-hour cycle, the clinical data breaks that assumption. The lines showing daily mean levels and circadian phases before and after light therapy are nearly identical. Melatonin profiles remain almost completely unchanged. Instead, look at this trend line. The actual biological driver of mood and sleep improvement is a consistent, dramatic surge in blood serotonin. Rather than just adjusting a biological clock, light acts as a direct biological intervention on the serotonergic system. It functions using the same chemical pathways targeted by traditional pharmacotherapy. A dose of sunlight triggers a chemical elevation of the brain's primary mood stabilizers. From a physics standpoint, not all light is biologically equal. This diagram shows the eye filtering specific wavelengths, isolating a bright zone measured as melanopic EDI, the spectrum that is most effective at triggering our circadian biology. There is an exact intensity required to trigger those biological benefits. Extended time in bright light that crosses the threshold of 50 melanopic EDI is the baseline necessary to begin dropping depressive symptoms. Timing dictates the potency. Clinical trials show that bright 2500 lux light applied specifically in the morning hours drives a 50% decrease in clinical depression scores for roughly a fifth of patients. That intense early exposure forces the body into a morningness chronotype. Consolidating your light intake early in the day strongly correlates with lower insomnia symptoms when night finally falls. Relying on dim 50 lux indoor lighting or waiting for late afternoon sun misses the biological window. High intensity and strict morning timing are necessary for achieving clinical results. Before making this a universal prescription, we have to look at the population demographics to see if this protocol applies to every single human brain. This split chart compares outcomes by age. For adults over 25, increased daylight is effective at lowering depression and insomnia. But for ages 18 to 24, the data shows almost no significant association. Medication also plays a role in how the brain processes the stimuli. SSRIs increase non-visual light sensitivity, yet objective tracking shows that medicated individuals do not naturally alter their habits to seek out more sun. High daylight exposure is also associated with increased arousal and hypomanic-like symptoms in certain populations. For these individuals, light acts as a powerful stimulant that can push mood beyond stabilization into over-arousal. Natural daylight is a potent biological trigger. Using it effectively requires self-awareness and targeted application tailored to your specific age and neurobiology. Moving from clinical analysis to daily application gives us a clear lifestyle strategy that can be implemented tomorrow. Step 1. Secure morning light immediately upon waking. This sets the circadian rhythm and initiates the serotonin response to reduce stress early in the day. Step 2. Prioritize intensity. Indoor lighting often lacks the physical energy required. You must get outside, especially leveraging free days, to hit those high melanopic EDI thresholds. Step 3. Monitor your physiological response. Treat light like a prescribed dosage, paying strict attention to any shifts toward hyperarousal. By treating natural morning daylight as a deliberate biological intervention, rather than just waiting for pleasant weather, we gain a predictable, cost-effective tool to engineer better mental health.